right, so today's lesson is power of powers. Okay, so the first thing I want us to do is look at our property. So it says a power of a power property. It says to find the power of a power, you multiply the exponents. Okay, to find the power of a power, we multiply the exponents. So here we have a to the m raised to the n. We're just going to take the m, multiply that times the n. So we have a to the m times n. Let's take a look at a couple of examples. Now, before we do both of the examples, I want to show you why multiplying the powers works, okay? So here we have 2 squared raised to the 5th power, okay? You guys remember last class we talked about the parentheses and the exponents right next to the parentheses. So here, this 5 is right next to that parentheses. Is everybody with me? That means that everything inside the parentheses is getting raised to the 5th power. So that says 2 to the 2nd power times 2 to the 2nd power times 2 to the 2nd power times 2 squared times 2 squared. That's 1, 2, 3, 4, 5. So yesterday, what did we learn when we were multiplying powers? So we add the exponents. So 2 plus 2 plus 2 plus 2 plus 2 is 10. So we've got 2 to the 10th power. Okay? So how did I get from those 2 exponents to the 10? We multiplied those 2 powers. Is everybody clear? All right. So when you're showing your work, you guys, you don't have to show all that, right? You just have to show that you are multiplying the powers. So you're going to write 2 to the 2 times 5, and that's equal to 2 to the 10th power. Everybody good? So if they tell you to write your answer using exponents, this is how you write your answer, right there. This is how you show your work, this is how you write your answer. If they ask you to write a numerical expression, an equivalent numerical expression, then you're going to multiply it out on the calculator, okay? You guys remember how to put it on the calculator? And then you're going to put in 2, and then you're going to press the XY button, that's raised to the 10th power, and that's going to give us 1024. Now I would like you to take a minute or two. Well, it'll probably just take a minute. And then do example 1B with your table partners. Make sure you're showing your work correctly. So, written as with exponents, we have 2 to the 15th because we've got 2 to the 5 times 3, that's 2 to the 15th. And then, as an equivalent numerical expression, 32,768. So now we have power of a product property. It says to find the power of a product, we want to find the power of each factor. Then we can write it as using exponents, and then multiply to get to the equivalent numerical expression. Okay? So to find the power of a product, we find the power of each factor, and then we will multiply. So here, we will take this m, right here, this m, let me highlight the m, and that m gets applied to everything inside the parentheses. Is everybody with me? So that's going to be a to the m times b to the m. So let's do a couple examples, okay? So here we have example 2 is power of product property, and here we have 2 bases. So we have a 7 and we have a 2. So we have 7 times 2 squared, all raised to the second power. Okay? Now, before we use our property, I want to show you why things work. Okay? So, again, we have everything inside the parentheses raised to the second power. Is everybody with me? So that means everything in here is multiplied times itself twice. So we've got 7 times 2 squared times 7 times 2 squared. So now we're going to put our terms together. So we have 7 times 7, that's going to give me 7 squared, right? That's equal to 7 raised to the second power. Times, now we've got 2 to the second times 2 to the second. When we multiply powers, what do I do to those exponents? You add them. So we have 2 to the 2 plus 2. Is everybody clear so far? So here we've got 7 squared times 2 to the 4th. Okay? Does everybody see that here we took this 2 and we applied it to everything inside? So that's going to be 7 squared. That's this one. And then we've got the 2 squared raised to the second power. 2 squared raised to the second power. That's this one. So this is our answer using exponents. Okay? And usually when they write your exponents, they put it in numerical order. So they would normally have the 2 before the 7. Is everyone with me? And now we can multiply. We can multiply 7 squared is 49 times 2 to the 4th power is 16. And then we've got 49 times 16, and that gives us, very good. Is everybody clear? So, here is how these are the answers. So this is the answer with exponents, written with exponents, and this one is the answer as an equivalent numerical expression. Why don't you go ahead and take a couple minutes to do example 2B with your table partners. On this one, we've got 2 to the 4th times 3 halves, all raised to the 3rd power. So here, that exponent 3 gets applied to everything inside the parentheses. So this is 3 to the 4th raised to the 3rd. So that's 2 to the 4 times 3. Is everybody clear with that? With this one? And then we've got the 3 halves, and you guys, I've just changed the 3 halves to a decimal, 1.5. So that's going to be 1.5 to the 3rd power. Everybody good? And then, so this, when we simplify that, that's 2 to the 12th times 1.5 to the 3rd power. To the 12th, when I put that in the calculator, 4,096 times 3.375 for 1.5 to the 3rd power, and multiply those, and you get 13,824. Okay. All right, so example 3, we have the power of a product property with multiple bases. So here, we've got 2/3 squared times 5 to the 0 times 3 to the 3rd, all that raised to the 3rd power. You with me? All right, so let's start with applying that exponent to everything inside the parentheses. Okay? So this, we've got 2/3 squared, so that's going to be 2/3 to the 2nd power raised to 3rd power. We multiply the exponents, right? So that's going to give me 2/3 to the 2 times 3. times 5 to the 0 times 3 times 3 to the 3 times 3. So now we've got 2 to the third. 2 times 3 is 6. Times 5 to the 0 times 3. What's 0 times 3? 0. Times 3 to the 3 times 3. That's 9. So yesterday we talked about this power. So I taught this a little early. So that 6 has to get applied to everything inside the parentheses. Remember we talked about that yesterday? So this is going to be 2 to the 6 over 3 to the 6. Okay? Times 5 to the 0 is 1. And 3 raised to the 9th power, let's put that in the calculator. 3 raised to the 9th power, 19,683. 19,683. Okay? All right, so now we're going to do this fraction. We're going to do this fraction, and then we're going to multiply times everything else. So 2 raised to the 6th power, let me put in the calculator, 2, and you guys do it in your calculator too, 2 raised to the 6th power, 64, right? So equals 64 over 3 to the 6th power, 3 raised to the 6th power, 729. Times 1 times 19,683. All right, so can I just put all of this over 1? Yeah. So when I have, so now I'm just multiplying fractions, so I just multiply straight across. Yeah. So we've got 19,683 times 1 times 64. So let's see. 19,683 times 64 gives us, let's keep that in the calculator, okay? And then down here we have 729 times 1 times 1 is just 729. And now I can just divide that, right? So my millions right there is still in the calculator. And then we're just going to divide this, divided by 729, and this is what we get, 1,728. So now I would like for you guys to do example 3B with your table partners. Okay, so here we're going to take this 5 and we're going to apply it to everything inside the parentheses. So this is 4 to the 0 times 5 times negative 1, no parentheses, times the 4, raised to the 4 times 5, times negative 2 with parentheses, raised to the 2 times 5. Is everyone with me? So here we have 4 to the 0 times negative 1 to the 20th times negative 2 to the 10th. So of course any number raised to the 0 power is 1. And then here, this one, no parentheses, the 20 only applies to the 1. So 1 to the 20th is 1. Apply the negative after. So this is negative 1. Then here, this 10 is right next to the parentheses, so it's the negative 2 that is raised to the power of 10. So that's going to give me a positive 1,024. So now that's 1 times negative 1 times positive 1,024, and that gives me a negative 1,024. The next power we're talking about is a quotient, the power of a quotient property. Now I think we actually did this in a previous class period without even knowing what the property was. But here, what we said was to find the power of a quotient. To find the power of a quotient, we find the power of the numerator and the denominator, and then to simplify, we divide. So we are going to apply this m to everything inside, the numerator and the denominator. So a over b raised to the m power means a to the m divided by b to the m. So let's do a couple of examples. So here, and before we use the property, I'm going to show you why this works. So here, 1/5 to the third power, of course, that means 1/5 times 1/5 times 1/5, right? Now, if I write the numerator using exponents, that says 1 times 1 times 1, that's 1 to the third power, over 5 times 5 times 5, that's 5 to the third power. 5 to the third power. You see how the exponent gets applied to the numerator, and it gets applied to the denominator. And that is the rule, okay? That's just using the rule. So, for example B, now we don't have to write this part. All we have to do is use the rule that the exponent gets applied to the numerator and the denominator. So over here, that 5 gets applied to the numerator and the denominator, okay? Oh, before we do that, we can also now just divide this. So now if we want to write a numerical expression, 1 times 1 times 1 is 1, over 5 times 5 times 5 is 125. And there we have it, an equivalent numerical expression. So going back to example B, we are writing 4 to the 5th over, now this is a -5 in parentheses, because there's parentheses right there. So this says -5 to the 5th power. Okay, so the exponent gets applied to the numerator and the denominator, and now we can simplify. So we've got 4 raised to the 5th power, that's 1024, over a -5, so we've got a 5 negative raised to the 5th power, and that gives us a -3,125. So -3,125. And there is our final answer. I don't believe we can simplify that.